Wonderful. So I think we will get started, and if you hear a pinging, I'll try and quietly let people in. Thank you. As I said, thank you so much for coming this evening. We have got a really interesting and actually quite alarming talk by an expert, Marcus Jones, who has come all the way up from Devon, and he is a lithium battery expert. We also have our very own Simon Cox, who is on the Stop Lyme Down team for disasters and has been looking in great detail at the BESS proposal. So we're going to explain to you, perhaps give you some information so that you can ask the questions of the Planning Inspectorate. And we hope it's going to be really informative evening. I thought just before we do get started, I might just remind everybody that the time has come now when we are asking people to register with the Planning Inspectorate. I don't know how to stop the pinging when people come in. I'm so sorry. So the time has come when we really do need thousands of people. The Planning Inspectorate want to hear, what do you think? What would the impact be for you if this goes ahead? So why do we not think that this should go ahead? Why is this the wrong proposal for this area? And we're asking you just to put in 2 or 3 bullet points, but get registered, because that means you're in the system. And the Planning Inspectorate will be able to examine everything thoroughly. They will listen, they will look at what views you bring up, and they will examine that next year. So it's very, very straightforward to register. And what you have to do is just either go onto our website, and you'll see there's a big circle, and then you just click on the link here, or go onto the Google, and you can here's all the details on how you do that. So it is very straightforward. All they want to know is just a few questions. Children and adults can register. They do ask you if you're over 18, but that doesn't mean children can't. And then your email, your postal address, and so on. And then there will be just a box, a straightforward box that you can then put in your feedback. And you will then be given an interested party reference number. Keep hold of that just in case you want to be part of the written representation next year, or part of the examination and the hearings. You actually can be involved in every stage if you wish. You don't have to be there. The important bit right now is that we're asking everybody to perhaps tell 10 people, tell your all your contacts, your family and your friends, please, about this, and ask them to submit a relevant representation as well. So lots of people coming in. So here, if you go to Google, you'll find the details just here. And this is what it will look like. It'll just say register, have your say. Just click on the green button, and then that will take you through all the different questions. So it really is straightforward. If you know what you want to say, it will take you about 5 minutes. So I'm going to pass over now to Simon Cox, who's going to explain what it's looking like for us right now.
Thank you very much for that. So first up, for those people who perhaps don't live locally but are joining this, because I know there's a wider interest in the batches from other groups across the country where schemes are proposed. This is the scheme that Island Green Power are proposing, and basically it's 5 areas, all linked up with the yellow line you can see. And it covers a huge area of the local countryside and will be visible from many, many miles away. And the area we're interested in tonight is the area in red, which is the BESS. And that's the key point of this tool. So there's the map in larger scale. And as you can see there, in sort of orange shaded bit, the BESS area, sort of orange pink, apologies for my colour blindness there, that is the area where the proposed BESS is. And the first thing you notice about that is it's right next to the main railway line, which in itself poses a risk, which we'll come on to in more detail later. And also the area here is obviously very scenic, very historical. The line that you can see going from sort of the top down to the sort of bottom left corner, that's the old historical Foz Way, used many, many moons ago between Exeter and Lincoln, if memory serves me correctly. And so what they're proposing is that this is a battery scheme. Now, if the one, as we understand it from Island Green Power, goes ahead, the containers we have here will be higher than that. So that means they have more battery storage units. This is a more traditional approach with those. So what you've got in those is individual cells which make up battery packs, and then those containers are packed full of battery packs and other switch gear to allow them to be delivered. So the key thing to take away from this is the reason they want lots and lots of batteries is not because we're going to get lots and lots of solar power. It's so that they can buy energy from the national grid in the early morning when the power is low and sell it back to the national grid in the early evening when the price is high. This is not green energy. This is arbitrage to make money, basically. It's what you could do on the stock market or any other trading environment. So what we need to do is to challenge the amount of battery storage on site. Because if we can reduce the amount of battery storage, it makes the scheme safer because it's the volume of it. And also, the batteries are increasingly stressed by daily charging and daily discharging. They will wear out a lot quicker, need replacing a lot quicker, because during the lifetime of the scheme, they would need to be replaced 4, 5, possibly 6 times. The BESS cabinets do contain smoke detection units, but they do not have any requirement as to where you place that smoke detector. So it is not based on the airflow, where it is most likely to detect the airflow, as you would do if you did a house design. There's no design requirements for that. Equally, the smoke and heat detection units are not required to be separately wired. So the assumption by the operators of the facilities that are in place now and are all planned across the country is that the unit will send a message if there is a heat or a fire. That is not the case. It could be faulty, but there is no separate wiring to send a signal, as you get perhaps with traffic lights, where the system sends a fault when it's not working correctly, so an engineer can replace it. Equally, the smoke detection equipment has no testing regime. If you go into, say, an office block, you'll see people occasionally going around with little cut sort of holders on the end of a big stick, and they put smoke up to test the detectors. There is no requirement for BESS units to do that. So if you get a major BESS unit that's been in for some while, the chances that some of the smoke detection equipment, some of the cabinets is not working is probably quite high, because they do suffer. They are in the open air. They're suffering from heat. There's a lot of air going through in terms of cooling and vibrations from those fans, etc., which could all impact on the accuracy and the working ability of those detection units. So what do Island Green Power say? They say an assessment of how the fumes, if there was a fire, could impact residential properties and species is provided. It is concluded that no significant effects are predicted should a fire occur. The proximity of the BESS area to sensitive receptors more than 350 metres away and that is the PWRO, that's the public right of way, and more than 600 metres from the nearest residential receptors. That is totally inaccurate, and we can demonstrate that by this fire. This was a fire in January this year in Moss Landing. People were evacuated from 3 to 4 miles away due to the scale of this fire. The fires give off toxic smoke, and this toxic smoke is harmful to health of animals, livestock, pets, and is also toxic at a lot lower levels than the prescribed level for evacuation if you've got underlying conditions like asthma, and also in young children. And we do have in the village of Hillowington a small primary school, and again they would be more prone to a toxic smoke than normal. So could that happen here? Because that's obviously America. People say to me, you couldn't happen. Well, on the 15th of September 2020, there was a fire in a BESS unit in Liverpool. This is a report from the insurers, Allianz. The BESS fire took 59 hours to extinguish following an explosion. If that happened here, the scale of it probably would be larger because there are more units. And I'll come on to why that's an issue, because the developers will have you believe that if there's a fire in one unit, it will be contained within one unit. And then could it happen more locally? Well, actually, you may not be aware, but there was a fire only on the 28th of March in Cirencester, a small BESS unit. Now, as you can see in that picture, and this is from the fire report from the operator, BESS unit number 1 has caught light. And so if you look at under number 2, has the BESS unit 2. The reason for this is, although they, as you can see with the picture, they are quite widely placed apart, is that the air intakes are not mapped and they're not determined to where the airflow is. So once you get a fire in one of those units, it does burn very hot because it's a chemical fire. It's not actually a fire, it's a chemical reaction giving off flames. That heat is drawn in, potentially depending on where the air intakes are, into neighbouring units. They get to 70, 80 degrees, possibly higher, and then there's a risk of thermal runaway in those subsequent units. And at that point already, in this one, there were already 2 units alight. And what actually happened, there was a huge delay because I believe that the safety culture within the battery industry operators is not as robust as it will be in other industries that have had things like the oil and gas industry, the aviation industries, for instance. So this picture was taken of a CCTV camera in the control room of GridServe. And this was taken at 13:45 on that Friday. And to anybody, you can quite clearly see that that one that was fully alight is that blob in the centre. That is the fire going off. And you can also see the heat in the other units. The cooler circles are the extractor fans doing the air. So what you can see is the extractor fans are facing us. So the secondary unit, the cooler light, had an extractor and an intake fan, I suspect, opposite the hot air. So you had hot air being drawn into that, which is why that one caught alight. So what happened on that day? Well, at 13:35 in the afternoon, there was a voltage variance detected within that one unit, the first one to catch fire, BESS 4. At 13:39, there were multiple spikes to say that the operational level had been exceeded and that the overall limit had been exceeded for that unit. Nothing as far as we're aware and from the report happened. At 13:39, there are a further 260 different alarms of faults recorded in that BESS. This was the point at which all of that battery unit become unsustainable because of the chemical reaction in some of the units. It would have spread to other surrounding ones and then the fire. The picture I showed you was taken at 13:45. That clearly showed CCTV footage of an explosion and flames from the top of the BESS 4.1. And then at 15:31, which you see is quite a long time after the initial chemical reaction and fire started, Gloucester Fire Brigade were called, but not by the operators of the site. They was called by a member of the public walking the dog. 6 fire appliances were deployed for what is quite a small fire. The first appliance did not arrive till 16:05, 4 o'clock in the afternoon, some hour and a half after the fire had started. This should have been picked up by the operator immediately, and certainly by 13:39, they should have known with the number of voltage spikes and 260 alarms that the something needed to be done, and they should have looked at the picture. I suspect the control units were not being monitored because if you saw that visual display, and it would have continued like that, that was a still from it, people would have known. So what are the risks, the wider issues for this? Well, there are capacity issues with Wiltshire Fire Service dealing with a large-scale incident. Obviously, for this one, probably the local fire brigade would be Malmesbury. They would turn up and they have insufficient water for not many minutes to cool the fire of that. And then we'd be relying on other ones from Chippenham. But 6 units were sent for the one in Cirencester. So a large fire here, possibly 10, 12 or more units would be needed. Down very small minor roads to get them in. And you also need access to get them in and out. Apologies for that. A musical instrument's just fallen over here. Anyway, if there was a large fire, it would close the main railway line, possibly for days if you had incidents similar to Liverpool, while it's dealt with. Because not only have you got the smoke, but that smoke is toxic. We cannot have trainload of people going through toxic smoke. The other thing is potentially flammable in some cases, and therefore a railway line operating near it could cause a spark from the overhead power cables or from the units under the train. So train services would have to stop, even if it was a chemical runaway, without a major fire. The other issue is the water supply. Where the BESS is proposed, there is no current water supply up into that area. And you'd also need bunding to retain the water that you spray onto the unit. Bunding is what that you get around your, say, heating oil tank. So if the actual tank leaks, it is contained within a wider container to stop it contaminating the environment. when I looked into this, when we did the initial feedback to Island Green Power, you need a bunding for the size of 5 to 6 Olympic-sized swimming pools just for a medium BESS fire. This would be a large one. So I suspect the bundling was insufficient. You can't let this water run into the environment without testing it because it is toxic. So you would need to be able to take it away to carry on cooling the fire. There is not the capacity to do that in any emergency situation. The toxic smoke is a risk to humans and animal health. And the safe levels, as I said, are below the levels. The Cirencester one, interestingly enough, we've got the report. The Environment Agency were phoned and they said there is no major urban areas, so we're not going to propose an evacuation. There were actually 2 villages, but by the time they made that decision, the smoke was under control because of the delay in calling the fire brigade. But that risks human, animal, and livestock health from doing that. And obviously then there's the groundwater contamination, especially if the bunding area was full from, say, heavy rainwater, and therefore that was limited its capacity. And then if you do get fire and a water contamination, there's a risk to the ground itself. We have actually asked under freedom of information. There has been no testing of the ground on the one at Cirencester, and no testing of the water course. The water from that site actually drains into a tributary and into the Thames eventually. So, but they've done no testing. That site, interestingly enough, is operated by a council in the north of England. So what would that mean here? This circle is the evacuation area in the event of a major fire. Truly, if the wind were blowing, the downwind end would need a greater evacuation, so it's more elliptical, but for the purposes of demonstration. So the villages of Gritlington, Alderton, Luckington, Shurston, Foxley, Norton, Lavington, and Santon St Quintin would all need to be evacuated. So that's a lot of people. I mean, the first one that you'd have to evacuate would be Lavington, very close by if the wind's in that direction. You've got small children there, parents may be away working. There's whole sorts of issues. You need an emergency plan to actually do that, because we can't wait for something to happen to do that emergency plan. But you're talking about there's a livery and a stud very close to the BESS. Again, you'd have to get those animals away, but how would you do that when you're trying to get fire brigades down the country lanes and horse boxes out the other way, people out the other way? It would actually be a chaotic movement of vehicles that would cause additional risks to people panicking and potentially driving faster than they should because of concerns. And then this comes on to the noise. Now, I will say this is not my expert bit. This is developed by somebody else. So if there are any technical questions at the end on this piece, we may have to answer them after the... So background. Decibels is how we measure sound, but it's not a linear scale. So if you go from 60 decibels to 90, it's not an increase of 50%. It's more like a doubling or a tripling. So there's going to be a lot of noise from this. And we have a sound here of an inverter. Now,
not at all quiet.
As you can see, that was quite noisy. That's a small inverter. The ones that Lime Down are proposing are twice the size of that, so would be louder. So I'll leave you just to look a minute at the various noises. But if I could just draw your attention to 110 decibels there, which is the third one up from the bottom, a loud concert or nightclub. Now, you all know how noisy that is, and I'm going to come back to that in a later slide. But when you have a concert club, it's very difficult to talk, and you can't hear yourself talk. So that's the sort I'm going to come back to in a minute. So the Stop Lime Down proposals have shown a number of contour lines for the sound, but what they're saying is that they're showing sounds from 30 decibels to greater than 50 decibels. So how much greater than 50 decibels? Well, that's the trick. They're disguising the loudness by saying greater than 50. And to give you a sort of clue of how that will work, it's like saying everybody going down the motorway is doing over 50. But that doesn't tell us that some people are doing 51, some people are doing 60, somebody might be doing 98, for all we know. It doesn't give you that impression of what the true speed is if you're doing a speed gun. And the same way, it doesn't give us a true level of what the noise is from this equipment. In fact, the noise figures are going to be significantly greater than 50 decibels. There's going to be 72 BESS containers, all generate 82 decibels. So that 82 decibels is broadly in line with the sound that you'd hear in a nightclub or a concert where you can't hear yourself talk. That is very loud. That's going to travel a long way, that sound. So this is the map provided, and it shows the daytime noise for the site. And where the arrow is where the BESS is. And those darker areas are where the noise is concentrated and it flows out. But obviously it's only going up to 50 decibels, and some of it's going to be louder. Certainly some of it's going to be up to 90 decibels. So that is very loud. And it also, the red area where they've mapped it to is only 500 meters. It doesn't exclude how the sound will go. But if you think about the motorway, and when you're out walking in the quiet countryside, how far away from the motorway can you be and you can still hear the noise and the rumble? How far away can you hear the train go along the train track? This sound will travel a lot further. It will also travel further at night in the stillness. And again, the nighttime noise, again, they put the noise there. The biggest noise during the night appears to come from the BESS unit. And again, that is significantly loud, as we said, that concert, that a noise in a nightclub or something. And that's very loud. And again, that will permeate further than they see, because it's not just 50, what they measured, it's about 80, 90. So it will go significantly further than they have mapped there. And when you've got on a still summer night, you've got your windows open, people are going to hear that, and it's going to impact their sleep and their quality of their health as a result of that. The second trick that Live Downey uses, as I say, they've not used any noise beyond 500 meters, but it will go further than that. So it will affect Shurston, Lavington, Corston. Those villages will be impacted by the noise, especially when the wind is in the right direction. It's very quiet in this area, very quiet in the countryside. Sound travels, especially at night. And we come back to the fact, if you're 500 meters from the M4 motorway, I can assure you, you can hear it. So this is what will happen there. And the third trick that they did was they got the planning inspector to agree that solar panels will be outside of scope of the noise because they're silent. No, they're not, because they've introduced moving panels. The moving panels will start off early morning and they will track the sun up and over, and then in the night they will go back to the flat position. But those panels all moving together, because I suspect they will all be timed to move together, will give a quite a noise. And that's not just in one site, that's in all of the 5 sites, in all of the areas that were on my original map that I showed you. So there's a lot of sound. But then they've been even more sneaky. They've got the Wiltshire Environmental Health Officer to agree that any noise measurements are going to be done between 5 a.m. and 7 a.m. in the morning. That is not realistic, because at 7 a.m., at certain times of the year, the panels will not even start moving, because if you look at it 7 a.m. this morning, it wasn't light enough to move them. I'm now going to hand over to Martha.
Thank you so very much, Simon. That's fantastic. But I'm going to pass on now to Marcus. Thank you.
Righto, what we'll talk about, what I'm going to talk about, is what's inside BESS. That's why we called it the secret life of a BESS. So what is a BESS? It's basically a dirty great battery. Similar to the battery you'll have in your mobile phone. If you've got an electric car, they're essentially batteries, nothing more than that, with power control systems connected to them. As I say there, battery energy storage system, BESS is just a jumbo-sized lithium battery pack, like those in electric cars, your phone or laptop. A BESS is required to smooth out the supply on the national grid. That's what they're actually used for. This BESS is made of lithium cells. Now, I'm not against lithium cells. They're brilliant things. They've enabled all the technology that we're using here today. They're great things. They can store a lot of energy, but they have a secret which makes safety challenging. when they release energy in an uncontrolled way. So what is a lithium battery? Right, LIBs. Now, so we clear something up, and I've had to do this before. Lithium ion. Lithium ion is not a chemistry when it comes to batteries. It's a generic term used to describe all the chemistries that are currently available. As I say, it's not a chemistry itself. Underneath there, you'll see all the common chemistries that are currently available. You might have heard of some of them: LFP, NMCs, LCOs. LFP and NMC are the most common and the most dominant ones. They were invented in the 70s and 80s for small devices. Here we have what is inside a lithium battery. This is what we call the jelly roll inside. We'll start from the cathode side, which is the one on the right-hand side, which is aluminium collector. That is where your active chemistry is, your LFP, your cobalt, and stuff. Going across it, you have a separator in the middle to keep it isolated electrically from one side to the other. And on the other side, we have a copper sheet of metal. All this is very, very thin, covered in carbon. This whole region, from end to end, is soaked in an electrolyte. And it's not water like you'd have in a conventional battery. It has to be an organic electrolyte, because originally the batteries, when they were first made, used lithium metal. And of course, lithium and metal don't make good bedfellows. When these batteries are created, to make them actually work, what we use is an SCI. What that is a layer of lithium salts on the carbon particles on the anode or the copper side of the battery. This is designed to limit the exothermic reactions which are natural with these chemistries. It's why your mobile phone gets warm when you've been using it for a long time. That's what they do. These chemistries naturally want to release energy rather than actually store it. So to be left to their own devices without the creation of SCI during manufacture, they will simply destroy themselves, because that's what they want to do. They want to transfer the energy you're putting in electrically into heat and gas. Okay. Cell forms. You may have seen some of them, you may not have done. The 18650 is the cylindrical cell. You probably come across those in some of the devices you might have. The pouch cell, you might have seen. The prismatic cell or hard case is probably what will be inside these BESSes. All forms are in all applications, so we haven't seen what's inside these BESS units, so you could have a combination of any of these. There we have some pictures of what modules actually look like. We have the pouch in the middle. We have the prismatic box, which are actually the toughest version. The pouch cell in the middle, although you find it in tablets and things like that, was actually developed for electric vehicles, believe it or not. And then we have the 18650 or the cylindrical cell. Now they come in different sizes. Again, you can find all these cell types in all different applications, so it's not consistent yet. Right, many modules make battery packs. As you see there, that's a module all made up. You can see all the cells all arranged in one box, and then you link lots of modules together to make a battery box. Okay. Normal operation. As I said before, exothermic heat production is a natural part of the function, isn't it? Whether you charge it or you discharge it. It's what they do, isn't it? And we're trying to limit that using this SCI layer, this solid electrolyte interface. With ions transfer across the cell from charging to discharge, or what is termed in scientific terms as the lithiation of the anode graphite, that layer on the copper side of the battery, on the anode side of the battery. Cathode to anode on charging, anode to cathode on discharging. All of this produces exothermic heat. Right, this is the interesting bit. This is what you'll be concerned about, failure. As I said before, exothermic heat production, it's the Achilles heel of these batteries. If that goes out of control and we release all the energy in an uncontrolled way rather than store it, Houston, you've got a problem. LIBs, or lithium batteries, are thermodynamically unstable. Their chemistries are really not supposed to exist. Lithium batteries don't commit suicide. It's not something they do automatically. They have to be abused. They're like people. They don't like being abused. What happens in thermal runaway is the SEI, this solid electrolyte interface between the carbon particles and the electrolyte, breaks down. And those natural chemical reactions of the cells take over. So it stops being a battery and starts becoming a thermogenerator. And as I say at the bottom there, that exothermic reactions will continue until all the energy in that cell, either you've applied to it or is in that cell, will be used up. Right. Thermal runaway. What is it? Well, if you had a number of academics in a room, you get 10 different answers. Put simply, it's a self-sustaining exothermic heat-generating chemical reaction, increasing temperature faster than it can be dissipated from the surface of the cell or the object in question, causing thermal decomposition of the chemistry inside. They're murdered by abuse. As I said before, they don't commit suicide. It's not something they do spontaneously. You have to abuse them. So it can be physical damage, overcharging, low temperature charging, high ambient temperature if they're exposed to, measurable manufacturing defects, water ingress, short circuit, defect or error of the BMS electronics. Currently, thermal runaway, as it's called, or failure, can be slowed but not halted. Now, this is the most important part. If you don't take away anything other than this, it means I've done something. Thermal runaway, or TR as we're calling it here, is heat, not a fire. No active fire is needed for it to be present. Second, it can occur in all chemistries, despite what you might have heard or you've been told, but it is expressed in different ways by different chemistries, changing the primary hazards. Here we have a little graphic, and if you look down the bottom, you'll see LFP and NMC. The green one is LFP, and the red one is NMC. You can see there's not a lot of difference between the two commencement temperatures. LFP will start at about 200 degrees thermal runaway. NMC is about 180. So the difference between them, as you'll set the threshold for new batteries, not old ones, there isn't really a lot in it. Remember, thermal runaway is not a fire, it's heat. No active fire is needed. What are the results of thermal runaway? The battery, one, can simply explode or boil off a vapor cloud. Low SOC, which is SOC means state of charge, can still result in this. No fire, an explosive atmosphere can be generated. That gas cloud that we were talking about. Fire or focused rocket-like flames at 1,000 degrees. Now that's if you get ignition of that vapor. Or vapor cloud explosion if the ignition is delayed, or what's called a deflagration, which is a low-speed explosion. It's not a detonation like you get with a bomb. Right, the venting of gases, vapor volume. Now, this is mainly for NMC chemistries, but it applies to all of them. 500 to 5,000 litres per kilowatt hour of capacity. So you can imagine, you can take the capacity and multiply it by the number of, take that and multiply it by the kilowatt hours of the battery pack you're talking about. Depending on the cell chemistry, different chemistries have slightly different vapor clouds, but the volumes are more or less the same. Two types of vapor cloud, there's not one, lighter and denser than air. One or the other will dominate. We don't fully understand yet how that works. All of these are highly flammable. Now we've got a lower explosive limits here. Now what's that? That's the lowest end of the explosive range. So for NMCs, that's nickel metal batteries, we have 6 to 11%. For LFP, which tends to be regarded as more safe, we get 5 to 80% because the LFP gas cloud contains more hydrogen. The danger of life and health, as Simon said, is well below that lower explosive limit. Again, we don't really have sufficient data on that yet. The cloud is corrosive and toxic. Fire suppression doesn't stop thermal runaway currently. There we have a nice picture of a UL lab test in the USA. You can see the box in the middle, the BESS, and that gas cloud that looks like smoke and steam is actually the visible portion of the vapor cloud. That visible portion is droplets of the organic electrolyte that's in the cells, that liquid that's used. Right. Safe distances in the event of a gassing event with no fire hasn't really been settled. Again, we don't have enough data on this. So the US hazmat band is around sort of 100 meters or so. It's a flammable and toxic cocktail. Now, this is just some of the things that's got in it. Hydrogen fluoride, CO, hydrogen, CO2, hydrogen sulfide, benzene, sulfur dioxide. So you can imagine it's not very nice. Right, thermal propagation is an important part of thermal runaway, and the two work together. Thermal propagation we can sort of control, but it's not a guarantee that it's going to get you out the woods. Propagation within the module from cell to cell, or from battery module to battery module, or rack to rack within a BESS, because all the modules are stacked up inside the box, will cause repeated vapor cloud explosion. I will explain what that is later. Increase in fire other cells going into thermal runaway. So you heat up other cells, those go into thermal runaway, and so on. As I said before, thermal runaway and TB can be slowed, but not stopped with current fire suppression systems. Buys useful time, which is brilliant, but it's not a resolution. We don't have a way of actually solving the problem instantly like you would with a conventional fire. Installation designs can affect thermal propagation, like Ross Landing, California, Brim, Surprise in Arizona, 2019. Right, depression of fire. Now, a lot of them talk about fire because it's big, fat, and obvious, and nice pictures. Knocking out the fire flips the risk to vapor cloud explosion. As TR and thermal propagation within those cells continues. You can't get at the cells, you can't get the water to them. You can cool them down so you can slow it, but you can't stop it because they're producing heat. It's like pouring water on the roof of the house when your kitchen's on fire. You know, the cells are inside a box, that is inside a rack. It makes it very difficult to cool that effectively. Water seems to be the best as it cools effectively. Use of powder increases the power of vapor cloud explosions, or the ignition of the gases. Gas CO2 head-on has no cooling effect, so is pretty much useless. Containment of thermal propagation, or protecting the rest of the undamaged unit, seems to be the best way to limit damage. Right, deflagration. Now, what is a deflagration? It's a slow vapor cloud explosion. You'll get the gases coming off and something will ignite them. It's a gas cloud. It's flammable. One way of doing that is to ventilate it. Now, the boxes here will have deflagration vents. That protects the unit. It won't stop the release of those gases because it's designed to protect the unit, not you. So it doesn't mean that it means the unit doesn't disintegrate into 1,000 pieces. Acid from the HF reaction with water. So if you're spraying water on it, you get an acid. This is a risk for firefighters. There has been cases where firefighters have actually had their skins burnt even through their protective gear because they've entered that gas cloud and water's been exposed to it. That HF, that hydrogen fluoride, turns to hydrochloric acid. There's also an electrical risk from stranded energy, arc flash AV, but it's not something that you're necessarily going to be. But this is a risk for the fire brigades that will be responding to this. Well, regulations. There are many guidelines. Now, I'm mainly from the marine industry. We have the same problem. There are lots of different guidelines. There are no real concrete standards for all of this. They focus on fire suppression. Fire. So you put the fire out, which then reignites the fire you've just gone and put out. Baseline regulations, when we have a domestic regulation, PAS 63100, for domestic installations, ISO, BSF.
Fantastic, thank you so much. Let's have a little look at, I'm going to stop the share. Yes, that's right. There's a barge. I want to show you, please.
Yeah.
There is a.
You want to know what a vapor cloud explosion looked like? That's just the gases exploding that's inside the boat. Nothing more than that. It's not a fire. But again, see the gases and it ignites it. Something ignites it inside the boat. Probably electrical equipment or something like that. It's a tiny scale. You imagine that happening in a box. Bits of deflagration vents and panels and things flying around.
Let's just turn this into fantastic. Thank you so much. Goodness me, that was interesting. I feel like my head is sort of blown apart. Actually, there's such a lot of information in there.
It's a lot to take in, but you know.
It is a lot, and I suspect there will be some questions, or we may want to go away and think about some questions. But we will, if we don't know the answers, we will make sure that we get back to you. I'm just going to have a little look if I can find any messages. So developers are going to argue, thank you for this question, developers are going to argue that examples of BESS fires often quoted are from the old chemistries, and the latest type, LFP, are less problematic. How can this be counted? The usual weighting assigned by the examining officer of grid-scale solar NSPs, NSIPs, to concerns about BESS safety is negligible. They often concluded that battery technology is developing rapidly and will soon not be a hazard.
Right, I think I can answer that one.
Can you?
So let's go back through that again, shall we?
Yeah.
Go back up. What is it? Yes, the latest types LFP are less problematic. No. It is often stated that LFP batteries cannot go into the. I've been firmly told myself, even as a knowledgeable person, I've been firmly told by many people, many YouTubers and many others, that LFP batteries are completely inert. They cannot go into thermal runaway. They can. Right? The key to this is that those statements, remember, it's a very simple statement, that thermal runaway is not a fire, and it doesn't require fire to be present. So battery do, unlike NMCs and others, what it'll tend to do, and it's one of the things that makes it so dangerous, as you saw with that narrowboat, they were LFP batteries. It'll simply boil off the vapor cloud. And eventually, because it heats up that much more slowly, eventually it might ignite the vapor cloud. More often than not, something else does, as you saw with the narrowboat. That was an LFP battery. Again, no fire involved whatsoever. So, talking to firefighters myself, they consider LFP batteries more of a hazard, because if you turn up to that boat, you'll think, oh, it's a contents fire. It looks like smoke. It's not. It's inside the car. Even if it's a car, you've got a container, a confined vapor cloud explosion. It's not a fire. That's the key to this. If you can demonstrate that you understand that, you can make a huge difference, because you're asking questions that, quite frankly, there isn't an answer to.
Is there anything else you wanted to add about that?
I just think to add to that, come back to my earlier point. If we get a vapor cloud from the BESS where it's located at the moment, all we need to ignite that vapor cloud is a train to go past.
You've got
a spark
ignition sources
from the overhead cable, from the electrics under the train, from the wheels on the track going over some points or some joints.
And as I said before, you've got two vapor clouds. So you've got the lighter than air one that might dissipate if you're lucky. You've got this heavier than air one that will travel along the ground and fall into the cutting where the railway is. I mean, I've been to the site. This cutting is deeper than a train, and it will build up. Take yourself on a nice, warm, hot, sunny day when you're more likely to get a thermal runaway, because the batteries are actually a higher ambient temperature around them. Imagine this summer, and that was operating. You get a thermal runaway, there's no wind, that heavier than air vapor cloud that's flammable drops into that, and then the fire brigade hasn't been able to shut the trains down, because they've only just arrived. They're not able to kill the trains. A train goes past and you get an ignition.
Crikey. Yes, this is saying, thank you for the information. You've said nothing about probabilities and statistics. Every day, millions of people charge phones, EVs, and home batteries. Do I now need an emergency evacuation plan from my neighbours in case my home battery goes into TM?
Any battery can go into thermal runaway. It's how you treat them. Probability and statistics. Yeah, quite often we say, well, the evangelists will say, well, EVs don't happen very often. The trouble is, you don't measure risk by one metric alone. I keep having this argument with people. Well, it doesn't happen very often. It's low frequency, but it's very high impact. So you only have to have once, and it can burn your house down. You prevent it by treating the batteries correctly, by using the right chargers, by making sure you use proper batteries, don't abuse them.
I will say there was a recent article in one of the newspapers saying that the incidence of domestic battery fires from solar installations on their roofs and the associated batteries is happening at a faster rate than installation. This is because those batteries on some of the early installations now are being degraded by being charged, and they're aging. So the increasing incidence of fires. You also get fires with the electric scooters, more prominently in London than you would probably be aware of them here. But I think you had some.
London Fire Brigade contact. I've got the London Fire Brigade. They are getting a fire, or 3 or 4 fires every week now involving scooters. These things are killing. Vapor cloud explosions are killing people right now.
Absolutely. If Melksham was avoided, because they were looking at putting the battery storage over at Whitley, and actually that was turned down due to groundwater. So why is it being considered here? Indeed, good question.
That's a very good question.
Yeah, a good question. Has anyone engaged GWR re the risk to train travel in the event of a fire? I believe we have been in touch with Network Rail, and they will be invited to submit their relevant representation, and we will be in touch with them. Let me go through other. Other questions, just going through them. Sorry, I'm just looking at this one as well. Oh, this is one for you. Older cathode chemistries generated oxygen during BESS fire, so could not be smothered. LFPs with olivine structure does not generate oxygen. Consequently, are LFP BESS fires easier to extinguish with water and specialist foams?
No, we don't. Again, despite what you've been told, LFPs produce large quantities of hydrogen. You're mixing it with the outside atmosphere. So whether they produce oxygen, they do generate oxygen, but a lot of that oxygen is used up in the chemical process. Thermal runaway is, you may not understand what this is very similar to what's called pyrosis. That's what it's closest to. It's thermal decomposition in the absence of oxygen. So you don't need oxygen itself. It just produces a huge volume of this chemical cocktail, then mixes with the atmosphere around it. Now, LFP batteries produce less vapor overall. So, you'd think you might win there, but they produce more hydrogen. So what you lose on one side, or you gain rather on one side, you lose on the other. Because you're producing more hydrogen, you need a lower percentage to have an explosive atmosphere than you would with any other chemistry. So it's not, LFPs are not immune to this. They take a bit more to push them into thermal runaway, so you can abuse them a bit more, but not that you'd recommend it. But they're still able to produce thermal runaway. As I say, they express it in a very different way. Therefore, it produces different kinds of hazards. So you're more likely to get that vapor cloud explosion without ignition, and then something else ignites that hydrogen cloud.
Can I ask you, you've obviously seen a little bit about, the plans that we have here for the Limedown Solar and the BESS unit, which is just between Norton and Lavington Village. What was your initial reaction? And you also had a little walk around this afternoon. What were your thoughts about the location, for example?
The location, I personally, I can't think of a worse place to possibly put it. Of all the places, all the land you've got around here, why would you put a BESS unit at the density they're thinking about in that particular location, next to a railway line in a valley, in a cutting? You've also got an electrical transmission line that passes the site. Of all the places you can possibly put it, you just put it on the other side of the site, out of anyone's way, or in another location on the other side of the railway. It's silly, really. People will know that these units can do this. Again, I suspect they'll be using LFP batteries, but that doesn't get you out of the woods. It means even if you get a vapor cloud explosion inside the unit, it blows its deflagration vents, it does everything it's supposed to do, you're still going to be releasing vapor. Right? You can put the fire out with water. It's not going to stop the thermal runaway. You're still going to be releasing vapor for hours.
I'm just checking any other. Could you, please, could Marcus give his opinion how far any BESS should be positioned from residential areas or major infrastructure?
Right, that's again what I was asking my contact in the States. Is there any prescribed distance or safe distance from a BESS that is gassing off, for example? No fire, just gassing. And the answer, there isn't really enough data on it. How this gas behaves in the environment, how it dissipates, how effectively it dissipates, what different weather conditions are. There's just simply, we don't know enough yet. So even in the States, there isn't a prescribed system yet because there isn't enough data. So the hazmat teams in the States sort of, as I said, talk about 100 meters or so is banded about. But again, there's no concrete set up because we don't know enough yet about how this stuff behaves in the environment. It'll dissipate. It depends on wind speed, weather conditions. Not enough has been tested to give us a conclusive solution that actually set up a standard procedure for handling it. So it's one of those things that you can ask them about, and you will know that there really isn't an answer yet.
Another question. We have a lithium ion BESS that's been approved to be built above a high pressure gas mains. What regulations are there for safety distances being located, as in to help the planners at the planning stage?
I would ask the question is why they're putting it over a gas main. I mean, you know, why?
Yeah.
You know the thing can actually go into thermal runaway. What are you doing? There's no need to be anywhere near a gas main.
And this is from, I think, am I right, in Seneca? And this is the NSIP that Ed Miliband approved within 4 days. It was recommended that it should not go ahead by the planning inspectorate. And Ed Miliband, in his great wisdom, he didn't visit the site, he didn't read the documents, but he approved it. Absolutely shocking.
Over a gas main, so I suppose the gas pipe is buried, but we don't know how far down or no. I mean, why would you do that?
Indeed. It's been buried only up to 1 meter, so it's shallow.
No, it's insane.
Is it?
It's insane. I mean,
it's terrifying.
You know, if you know, not that it's likely to damage a gas main, but it depends on what happens. That's another unknown. I mean, you know that, you know, it's known that thermal runaway can occur. You now understand, I hope, what thermal runaway actually is. And, you know, knowing what I've told you, would you do that? No.
The examining authority do not understand risk assessment. Examples from completed NSIPs show that they are persuaded that there's low likelihood means it's acceptable.
But again,
just because it's low, it doesn't mean it's not.
It doesn't mean say it's, you know, understanding risk assessments. Again, you get this again and again and again with EVs. Oh, it doesn't happen very often. Yeah, I only had to happen once. It's, you know, it's low frequency but very high impact.
This is the whole thing with risk assessments. You've got to look at the frequency and the impact.
Yeah.
And my view that with anything where you're doing it, you do not want what they call the top end of a pyramid if you're doing stuff in highways, which is a fatality. And if you look at the BESS, Eddie, you had a major fire, and certainly some of those chemicals could result in a death from people who've got underlying health conditions or of respiratory disease, given the gas. And the other issue, if I put my hat on for the wider major instances disaster, is all this traffic driving up these narrow country lanes with people who may not be used to driving like local residents are at country lanes. And we've got a sort of unique number of cyclists, equestrian users, etc., that you don't get in other areas because of the very nature of the lovely scenery, the historical area with the Fossway and with Malmesbury, etc. So again, that is a risk that we need to raise, in my view, with the planning inspectorate.
So how can we re-educate the examining authority?
If you put in objections effectively using this technical data and maybe do a bit of research yourself, you will be able to pose questions that you will know there is no answer to. And you could make life very, very, very difficult because you're not, you know, you're not concentrating on the fire, which a lot of people concentrate on. If this is the, you know, again, it's reducing thermal runaway to a fire that's allowing all this to happen. Once you realise that it's not a fire and it's actually more complicated than that, it opens out all of this, you know, the issue with LFPs. Yeah, it's not a fire with an LFP, gassing event.
It seems that cooling is really the only way to slow down a thermal runaway.
Yeah.
Don't developers put internal cooling sprinklers between the cells so that they can cool individually in an emergency?
There has been, I'll admit, there has been some success with injecting foam. This is something that's being used by a marine system, but what they do is they admit, first of all, the developer admits, the company that making this admits they're not stopping thermal runaway. They admit they can't do that. What they're doing is controlling that thermal propagation within a module. So you're trying to protect the existing cells and stopping it. Spraying water won't necessarily, it will slow it down. So you're controlling the propagation, so you'll get less cells affected.
BESS safety is being discussed in Parliament. Do you have any knowledge of where the discussions are, and have you been able to contribute to your specialist knowledge?
No.
Okay, so, okay.
I have been engaged with MPs, but there's a great deal of need for education.
Yeah. This person says BESS plus vapor plus train spark. That's about 800 people on a mainline train.
You know, I feel it would be unlikely to affect the train. The train would pass, but what you'd end up with a gas explosion around the train. It might break the windows, but you've got to remember this vapor cloud explosion in your case, unlike on ships, is not necessarily going to be confined. It's going to be out in the open. So you'll get a big ball of flame and it will disappear. It will be alarming more than catastrophic, but it's really the risk to the firefighters that are responding. They're standing by the BESS unit. And if a train goes past and they're standing in an explosive atmosphere, they're going to get hit by it. It will dislodge their masks. Then they're exposed to the toxic gas. It's not good for them from emergency response.
And presumably the cloud, that vapor cloud that comes up, which is full of, it's toxic, that then lands and contaminates the soil.
Again, we don't have enough data on this.
Yeah.
It's this unknown environmental aspect. Yes, we know the runoff is toxic, but how that behaves at distances in water, how it dilutes, not enough has been done yet to actually establish anything concrete.
Is there a reason BESS are not located in a confined environment, for example, underground?
Yeah, vapor cloud explosion. I mean, you imagine you've got a vapor cloud explosion in the open air is bad enough. If you confine it, you increase its power. If you want to know you've seen what happens in a confined space of the narrowboat and what it did to the boat. It's taken the windows out, thrown bits of about the place. There is video from America of confined vapor cloud explosions happening inside a double garage. Typical American house with a double garage door. That door is blown clean off. I've got pressure assessments that were done by UL, and they're looking at a force of about 6 to 7 tons on the door. And it literally blows the door about 30 feet.
Crikey. Please could Marcus create a list of issues with scientific background to ask the examining authority in the right manner? Well, we'll be in touch with that.
Yeah, we could try and do that with a basic list of these are the hazards that we understand right now. A lot of that information you can find from the links on that final page.
Next slide, thank you.
Yeah.
Yes, on that note, we will be obviously putting this presentation up on the website, and you are very welcome to send any questions into info@stoplimedown.com. So the takeaway from this last question. So the takeaway from this is that the BESS units need more design work to mitigate and minimize the results of a thermal runaway should it happen. Until such is in place, it's irresponsible to install such large units.
Yeah, I'd agree with that. And this is what was learned from the Arizona explosion in Surprise in Arizona. This is what changed everything in America. This is why you've now got the 9540A standard in the States, because they realized from that explosion in Arizona that there was an issue. And it's actually improved designs quite dramatically in the States.
Thank you so much. I'm just going to share this one more time, just to remind everybody, please. So it's coming up to a very critical moment for us. The Planning Inspectorate want to hear from you, and I hope now you might feel armed with a few questions that you might want to ask, and ask the Planning Inspectorate. So just little bullet points. It doesn't need to be detailed at this point. This is a moment where it's called relevant representation, basically feedback to you and me, but it's making sure that you're in the system so that if you want to ask more detailed questions, you can at the written representation stage, which will be next year. The examiner, they will look at all those issues that you and I raise, and then they will hold hearings on them next year. And so it's so important that you do ask those questions. Whatever is worrying you can be asked, but it doesn't need to be detailed. It literally will take about 5 minutes. Just in case you missed the start, you can go onto our website, stoplimedown.com, and there's a big circle. Just literally click on it, and you will find, you will get onto a page that looks like a bit like this. And you click on the little green button, register to have your say. And they will just ask you some simple questions. You can register for yourself, but also don't forget you can register as well for your business. So do put in two relevant representations. It's really important that we have the numbers registering. Children and adults, it doesn't matter where you live, please spread this far and wide to all your address book, and certainly please at least 10 people. And then there will just be a little box. A box that will say, I'm not sure where the box is, I haven't got a picture of it just there, but it's just a box literally, where you just put in your feedback, and it can be just 2 bullet points if you want to. It does not have to be detailed. You will be given an interested party reference number, and that just means that if you want to give more feedback, or you want to be part of the examination, then you can be. If you miss this window, the 9th of January, then it's too late. And we're really encouraging all parish councils, please, you must also put in a relevant representation so that you can have a voice. If we miss that window, you don't have a voice, it's too late after that. So please be sure to spread the word. It really couldn't be easier. We certainly will be sharing this this presentation, the recorded version, so you're welcome to access it. There's just one last, can you comment on a BESS site that has been improved next to a large reservoir that feeds 30,000 individuals, businesses and livestock?
I don't know anything about that.
We don't know. It's in Anglesey, North Wales. We
Judicial,
don't know about
is that judicial review at the bottom there?
Yeah, in the process of review.
Yeah,
process of JR. Do you send any other detailed questions to us? I think we're going to.
I mean, on the last slide there is my email.
Yes.
So if you want to contact me directly, even if I don't know the answer, I may be able to go to somebody who does.
Yeah, fantastic. Yes, Mark has been really kind to say that he would be very happy to forward any questions to other people. So you've got contacts all over the world, really, haven't you? So we will make sure we do that. We'll share all of this. It will be up in the next couple of days on the website. My apologies for the completely unprofessional start without you actually seeing any of the slides. So sorry about that, but hopefully you saw most of it. And just don't hesitate to message us if there's anything we can do to help you. Please spread the word, and huge thanks for all your amazing support. We have got all the specialists working and the experts working extremely hard now, and scrutinizing all those thousands of documents and pages. They are on board. I must say thank you to all of you who have already joined the 1000 Club. We're just bowled over by the support from the community. You have been so generous. Just £10 a month it really has meant that we've had the confidence to go ahead and secure all these different experts. So thank you. As I've mentioned before, we do need to raise another £300,000, and it is an eye-watering amount, just so that we can have all the legal representation and everything. So if you haven't yet joined our 1000 Club, would you think about it? We would be enormously grateful. The details are on our website. Do just pop there or just send me an email. But huge thank you to all of you who are already supporting us in so many ways. We are incredibly blessed. We have an amazing team, absolutely extraordinary team, with people working tirelessly for the community. We want to safeguard this area of the Cotswolds for future generations, for our grandchildren. And it's so important that we have our voice heard. So this is our moment, and we really do hope that you will take up this opportunity. But just for now, thank you so much, everybody, for joining us. We're enormously grateful, and thank you both. Thank you, Simon. Thank you, Marcus. You've come a long way.
The other thing I can add is I've written a number of articles for Marine, because that's my background. They are available on my website.
Fabulous, thank you. Well, we will make sure we share those details.
You can share that. and it'll give you a rundown of what I've done. It's explained for, again, as I say, marine people, but it gives you the same basic information.
Yeah.
What the hazards are. That's what we're trying to grasp.
Exactly.
The more we understand the hazard, the safer we'll be, because we stop using the batteries in silly ways.
Yeah, absolutely. Just a sort of final message. Thank you, Catherine, for parish councils. Please do remember that you can put in a relevant representation in as a council, but also individual councillors. We would love you also to please put in your relevant representation. So, but thank you all. Enormously grateful for bearing with us and for all your support. And we will, I dare say, meet again. But thank you very much. I'm going to close the meeting now.